Now we will see RAG implementation using similarity search instead of a simple SQL search. If you remember, the only difference between RAG implementation using similarity search and SQL search is the retrieval portion. In the retrieval portion, which is step number 5, instead of retrieving the solution from the knowledge base using a simple query search, in similarity search, what we will do is we will match the user's prompt semantically with the issues in the knowledge DB and then retrieve the correct solution for it. Rest all steps are the same. Once we retrieve the correct solution, we augment it to the user's prompt, send it to the LLM, and get step by step instructions. Hence, we will only concentrate on step number 5 and see in this example how to do a similarity search based on user's prompt. Rest of the steps you can work out as we had done in the previous example of SQL search. Before going through the entire example, we will see a small portion where we get embeddings for a particular sentence. Embeddings, if you remember, are nothing but vector representations, numerical vector representations based on semantics, context, etc. Here we will call Gemini's text embedding model to give us embeddings for a sentence that we will pass to the model. A very small, simple code example. Let's run this code. And here you see we get the numerical vector representation or the embeddings for the sentence what is meaning of life that we had sent to the embeddings model. This gives us the basis to write the code for similarity search. Now this is the code for similarity search using embeddings. Here step number 1 is to read the database file as we had done previously. In the second step, we create embeddings for all the rows in the issue column because that's what we are going to compare semantically later. This particular method calls the text embedding model of Gemini and gives us the embeddings for all the rows in the issue column. After which, we create the embeddings for the incoming query. Once we get this embedding, we now have the embedding for the incoming query as well as embeddings for all the rows in the issue column. Now we do a comparison using cosine similarity. Basically, this is an algorithm which will tell us which is the closest matching embedding between the embeddings of the issue column and the embedding of the incoming query. This is very important. We have created the embeddings for all the rows of the issue column. We have created the embeddings for the incoming query. And now we are comparing these embeddings to get the closest matching embedding. Once we get that closest matching embedding through this loop, we will actually get the possible solution corresponding to that issue. So in this case, the incoming query has why does the temperature of my laptop increase? Now remember, we didn't have anywhere temperature as a keyword in the issue column. What we had was that the laptop heats up as one of the issue. Because we are doing similarity search, we don't need to have the exact key matching keyword. We are actually doing a semantic search and getting the closest matching issue and the corresponding solution. Let's run the code now. There we go. Here you see the possible solution it came back with. It checked the task manager and update drivers. And this is based on the incoming query which had temperature of the laptop increasing. Let's suppose we change the incoming query to say laptop gets warm after Windows updates. So we don't have the word heat and we don't have the word temperature. We are just saying laptop gets warm. And let's see if we get the similar results as we got before. As you can see, we got the same exact solution back. That means the semantic search is working well. If you remember, there was an issue regarding Wi-Fi. So instead of incoming query saying that the laptop gets warm, if we put in network is not available and then run this, it will match to the other Wi-Fi issue and give us the solution as restart router and reinstall Wi-Fi drivers. This was a very important example to enable you to implement RAG using similarity search. This opens up large number of use cases for GenAI systems. As I said, all the other steps are very similar. The only difference was the retrieval portion which we saw in this example.